I'm John McQuay with 8541 Tactical, and this is Mail Call Mondays, the show that answers your questions about precision rifles, optics, and equipment. Welcome to another Mail Call Mondays, and this Monday we are going to talk about this guy right here, which is the Mega Arms MATEN 6.5 Creedmoor build, and how well it is working with the Nosler 140 grain reduced drag factor bullets. We've got in a couple of boxes of these bullets, and I've been trying to get them to work with this rifle to get everything ready to go shoot the Guardian long range match this next weekend down at Frontline Defense in North Carolina. We've had some touch and go, we've had some things that we've had to experiment with and try to figure out, and we will talk about that in detail in just a few minutes. But first, we've got a question to answer from Alex. And Alex says, "Hi John, I've got a question about glass bedding. I know that you've touched on it in the past, but I just want to know if bedding increases accuracy as much as people say it does, then why don't chassis require bedding? Like for example, Cadex. Even Macmillan doesn't recommend it. And why do some even bed a small portion of the barrel when in a chassis it's free floated the whole way? Love your channel, keep it up." Well, Alex, really, first of all, let's take a look at what we're trying to do when we bed a action into a stock. Very often when a stock comes out of the machining process, they inlet that stock a little bit of oversize. The oversize, especially back in the day, was necessary because you may not have had the most precise process cutting that channel and cutting the action recess in the stock. So there was a little bit of slop left in there. Then when you drop in an action and bolt it in, under recoil, that action can move around in that stock just a little bit. So what gunsmiths would do and precision rifle builders would do in order to take that up is they would go ahead and bed the stock. Especially back in the day when you were dealing with wood stocks, which would have dimensional changes based upon the humidity in the air and the temperature, that glass epoxy bedding would give you a little bit of a buffer space in there that was more resistant to environmental changes than the actual wood the stock was made out of. So that consistency then translated into better accuracy from the system. Now make no mistake about it, no chassis or stock or bedding system can make accuracy. The only thing that it can do is allow the barrel and the action in the system overall to perform to its best. It can't take an inaccurate system and make it accurate. All it does is fix a problem. Now, since all we're doing is fixing a problem, now when we move forward to our current days where most everything is computer manufactured, instead of having a guy with a fixture and a machine milling out the inside of that stock, you've got a CNC machine that is cutting an exact pattern and is cutting the exact same pattern every time in that stock. Now you can get a much tighter fit between the action and the stock while still accounting for a tiny little bit of manufacturing variance between stocks. Now, because we still have to allow for that tiny bit of manufacturing difference, you will never get a stock that is an absolute perfect match to the receiver that you have unless somebody took that receiver and put it into a computer program and measured it perfectly and then cut it. And even when you do that, I don't believe that you're going to get as exact a match as you easily can do with glass bedding. So a lot of precision rifle builders will still prefer to get a stock in, even a stock from a company like Macmillan that uses very high tolerances when they machine that inlet. They'll prefer to cut it a little bit oversized, put glass bedding in it, bed the action into it. That way there is as perfect a match as they can get without causing a mechanical lock. Now, if you switch over to the bench rest community actually wants that receiver, that barreled action, to be locked in to that stock. So very often they will glue the action in. And in gluing the action in, you remove pretty much any chance of that action moving from shot to shot in the stock. So your torque and your harmonics are absolutely perfect from shot to shot. I shouldn't say absolutely perfect, absolutely consistent as we can make them from shot to shot from the mechanical system. Then they just rely on tuning their loads and sometimes on barrel tuners to get that shot to shot consistency. When we go over to the tactical rifle side of things, or the PRS competition side of things, we're not shooting from machine rests. We're not bolting the rifles to the bench. So a very tiny bit of harmonics difference in the rifle is not going to be something that even top-notch shooters are really going to be able to see. We still want a really good fit. We don't want to allow debris to get down in there. We don't want to allow water, that kind of thing, to get in there and start to affect differences between the action and the stock. But in most cases, the tiny bit of gap is not going to be enough to cause a change in impact downrange that you're going to be able to view when you're shooting off a barricade, or even when you're shooting prone with a rear bag, that kind of stuff. When you look at chassis, chassis are designed a little bit differently, and you specifically mentioned the KDEX. KDEX chassis would be very, very difficult to bed because the way the KDEX chassis is designed, it has a recess for the recoil lug, and you always want the rear face of that recoil lug to be hard against the front face of the recoil lug recess. That's what keeps that front to rear movement from occurring under recoil. So it gives something hard for that recoil lug to impact against, and you really don't want any space between the two. So KDEX has that set up, but then to support the rest of the action, they have hardened steel bedding points. There are 4 bedding pads in there, 2 in the front and 2 in the rear, that the action bolts down to and sits on. And the idea there is that you have these 4 small pads, and that once you torque it down, contact should be pretty consistent between those points, and it really shouldn't change through recoil. We've had very, very good response from our KDEX Strike 30 chassis, and I really have not seen any accuracy difference between that or between bedded in systems. It seems to work very, very well. Now, when we look at other chassis systems, like say the Accuracy International chassis system, or AICS, I have seen gunsmiths that have bedded Remington 700 actions into the AICS before because they were getting some kind of movement in that. A lot of that I think may have to do with Remington's tolerance when they polish the outside of the receiver. Some may have to do with just some manufacturing differences there. I haven't run into a situation where that's been necessary, but I have seen gunsmiths do that before to try to fix a problem. It's not something that needs to be done on a regular basis. When you switch over to stocks like the Macmillan that you mentioned, when we got our A5 in, we shot some groups with the A5 prior to bedding it, and we shot some groups with the A5 after bedding it, and we really didn't see a change in the group size of the complete system pre-bedding and post-bedding. It worked very well on both sides of it, and that's a test to Macmillan's ability to inlet these stocks very, very closely. Now, our A5 did come pillar bedded, so it had aluminum pillars already set into it, and those aluminum pillars are glued in so they don't move at all. What that allows us to do is get consistent torque every time we bolt that action together, so we don't have to worry about the environment causing any kind of changes in them. You'll get a slight temperature variation because aluminum does change dimensions very slightly with the temperature, but not enough that we have seen a great shift between summer to winter zeros. So we have that. That's pretty much the bedding versus chassis. If you want the absolute most chance of keeping that consistency between the action and the stock, then bedding is the way to go. However, if you want the freedom to be able to easily take that action in and out, and you don't need that absolute last tenth of accuracy, then a chassis system, a high-quality chassis system, can definitely get it done for you. Now, the bedding area underneath the chamber is generally what you're talking about when you're talking about a short section of the barrel. That will change from gunsmith to gunsmith. Some like to do that with heavier barrels because they feel that it gives better support to the barrel instead of just relying on that section of barrel that's in the shank. Some don't like to do it on high volume rifles where that barrel is going to get really hot because that chamber area is going to get hot. And the idea is that the heat in that area can affect the bedding. So sometimes they will leave that open. And it's really up to what the smith wants to do, what they think is going to be the most accurate for that application. One thing to bear in mind, though, is that if you have a pad underneath the chamber area bedded, then when you go to have that rifle rebarreled, you may have to grind that out and have that rebedded again. Where if the bedding stops at the recoil lug, then very often when the rifle is rebarreled, you won't have to have the stock rebedded because the section of the action, if they're not actually truing the front face of the action, the section that is bedded should be unchanged between barrels. So just something to keep in mind about that little pad in front. My preference is to leave the entire barrel unbedded, the entire barrel free-floated, and that's just because I run lighter weight barrels. I usually don't run huge, heavy barrels. So opinions will change from smith to smith. It seems to be on that. So I hope that gives you a little bit of idea. There's not really a totally right or totally wrong situation. Remember that when you bed an action into a stock, you are pretty much marrying that action and stock together for the life of that system. If you decide you want to put another action into that stock, then you're going to have to grind that bedding out and you're going to have it rebedded. Whereas if you just take, say, a Macmillan A5, pull it out of the box, then you can pretty much grab any Remington 700 action you have and drop it in there, and you're going to be good to go without having to rebed it each time. So if you switch things around a lot, bedding may not be for you. For me personally, I don't bother with any bedding in chassis systems. Some chassis just won't allow it. You would have to do some considerable changes to the inlet in the chassis. Others, it's just not necessary. So I would tend to try to fix problems a different way than actually bedding a chassis or an action into a chassis. So hope that answers your question or gives you a little bit better viewpoint on the whole bedding versus chassis systems versus unbedded stocks. Now let's talk about the guy in front of me. Now, first of all, I'll give you a little bit of background. This rifle, originally, when we built it up through our Mega Arms MATEN 6.5 Creedmoor build series, which you can find the playlist to that down below, we decided to work up the initial load with the 140 grain Hornady boat tail hollow point bullet. It worked very well in this rifle. But I knew I was going to need some bullets to go shoot Guardian. My 140 BTHPs were gone. I had pretty much run out of them. I have some 140 ELDs running around here, but I hadn't actually worked up a load for them yet. So I wanted to try the new reduced drag factor bullets from Nosler. The numbers on them look to be pretty good. I mean, the box in front of me is advertising a G1 of 0.658 and a G7 of 0.330. So that is a really interesting coefficient. And actually, it seems from what I've been gathering from a lot of people out there that the drag factors are actually underrated for this bullet. That the G7 guys are using closer to a 0.360 to get on. So they say if you use your 330, you're actually going to shoot over at longer ranges. So that was really nice to hear. When you look at these guys and you compare them to, say, the Hornady 140s, they definitely have a sharper design. They are more of a VLD design than the Hornadys. So I was really excited to try them out. I didn't want to go through a full load workup. When I originally worked up the 140 grain load for this rifle, we picked a really fat accuracy node and we stayed kind of lower in the velocity. So we really weren't pushing velocity, again, because this is a gas gun. And when you start to push the upper edges of velocity, you can run into problems with gas guns a whole lot quicker. We also are running a standard bolt, not a high pressure bolt in this, so I didn't want to run into problems with blowing holes in primers every single time. We may change that up a little bit. We may push pressure a little bit more in the future when we get some Lapua 6.5 Creedmoor brass in, because those use small primers now. And that's specifically to help alleviate some of the pressure issues with higher pressure 6.5 Creedmoor cartridges. So for now, we were running a fat accuracy node, which means I pretty much had a little bit of leeway one way or the other before the group started to open up. It was a 140 load, so I felt pretty confident with taking the 140 RDFs and dropping them in without doing a full load workup. Now, we always drop down and fire a couple of test cartridges as we work up to make sure we're not going to run into pressure signs. When you switch any component out, you want to drop down and come back up, be that primers, brass, bullet, etc. That way you don't get caught in a bad situation. So we dropped down a little bit, checked our pressures, came back up to 41.5 grains of H4350, which was the accuracy load that we were running with the 140 Hornadies. We didn't see any pressure signs. Loaded up a test run of these cartridges, and initially when I was checking the pressure and checking other things, I was single loading the cartridges. What that means is I put a magazine in, I would lock the bolt back, I would insert a cartridge, and I'd take my finger and I would actually run the cartridge all the way up into the chamber until it was seated solidly forward in the chamber. Then I would reach over and I would drop the bolt, and thankfully with the MATEN, we've got this nice little button right here to drop the bolt, so I can get in position, drop the bolt, go off safe, and fire a shot. And I would do that a couple of times and get some groups laid down. And what we seemed to notice is we would get a really nice tight 4-shot group and we would kick a flyer out. And this would happen pretty regularly. I'd try it single loading every time, so we know that we're not getting a bullet jacked off center when it hits the feed ramp. That can happen from time to time if you're running really light neck tension and the bullet doesn't feed smoothly. That bullet's hitting that ramp, or it's hitting the locking lugs in the chamber pretty ferociously, and you can knock a bullet out of center, and depending upon the bullet design, it may not recenter on the rifling. The sharper nose bullets tend to be more sensitive to that initial alignment than your more round bullets. So VLD type bullets really want to be centered when they start. They don't want to have to center when they jump. And that's just what we noticed here and there. So this flyer was starting to bother me a little bit. I loaded some up from the magazine because I wanted to see if maybe I was not loading them very consistently, and just wanted to test both ends of the spectrum. And I noticed even running from the magazine, we had some issues. But the biggest problem I noticed as soon as I loaded them up from the magazine was with a standard PMag, PMag LR20, they wouldn't actually feed. They would come forward, they would start out of the magazine, and then because of the design of the AR chambers, you have your opening for the chamber, and then you have about a 45-degree chamfer, and then you have the back of the barrel, this nice flat ring there. And what would happen is the bullets would come out, and because they are so long and so pointy, that means they are narrower at the same point on the bullet versus the Hornady 140s. They wouldn't actually contact the locking lugs or the ramps on the locking lug to bring the bullet up. So it would just shoot forward, and the point of the bullet would slam right into the exposed back of the barrel and would bring the whole works to a stop. So that was somewhat curious. I brought it back, played with the seating depth a little bit to try to see if that could solve it, and we really couldn't get it solved. We kept running into that issue no matter what I set the bullet to. I could seat them almost all the way back into the case to where I just had enough bearing surface in the neck of the case, and they would still run straight back into the back of the barrel. So that ran into my next problem. I had to take one of these magazines, and normally if you have a steel magazine and you have that issue, then you just kind of bend the feed lips a little bit until you get that bullet to ride nose up enough to be able to go straight in. Well, I didn't have any steel magazines. All I had was my PMags, and you're not going to bend the lips on a PMag. They are what they are. So we did the next best thing. We broke out the Dremel, and I basically cut away pretty much half of the feed lips on the PMag. I cut it back little by little until I could get the cartridge to release at the correct spot on that forward travel and jump up. That way it could make a clear running leap into the chamber. And that seemed to resolve our feeding issues, but I had already ordered a set of steel DPMS magazines. Now, interestingly enough, the steel DPMS magazines, when they came in, I bent the feed lips a little bit until we could get the bullet pointed up enough that it would feed straight. And then we ran into the second problem, that with the feed lips bent enough to allow that, they would run into the carrier and not allow the bolt carrier to go forward. So the steel mags didn't help us at all. We would actually probably run into the same situation here, where I need to cut away a section of the feed lips in order to be able to make it work. And we may play more with that later on, but we just ran out of time on it. So first thing, to get the RDFs to actually feed at magazine length, I needed to cut the feed lips back and recontour the front here so that the cartridge pops after about a little more than a ½ inch of travel. Thankfully, that still allows us to hold a full 20 round stack in here and shake it, be vigorous with it, and not have any cartridges pop out. We haven't had any malfunctions yet running that, but of course we haven't had a ton of time running them, so that's yet to be seen. But at least I figured out that works, and I'll have to modify another PMag. PMags are fairly cheap, so I wasn't greatly concerned about irreparably damaging a PMag. If that happens, then you just throw it in the trash can and start over. Like I said, they're very cheap compared to the ammunition we're putting through this thing trying to get it to work. So got the magazine fixed, loaded up some more cartridges, and this time when I loaded my cartridges up, I made sure that the charge was absolutely perfect on each one. We're running matched brass. The brass was one-time fired, 6.5 Creedmoor brass from Hornady. It actually came out of some of their 140 ELD ammunition. So the brass was as close as I could make it without actually turning necks and getting into that craziness. I measured the neck tension across all of them. So perfect charge, perfect neck tension between 10 different cartridges. The only thing we didn't do is we didn't actually weigh the bullets between each one, because that's not usually a step that I do. We may go back through on this next run and actually weigh each bullet to make sure that my flyer is not actually an odd bullet. So weighed charges, made sure the cases were as close as I could, checked the seating depth on each one with a comparator to make sure the seating depth was good across all of them. Took them out, and again, shot them hand loading each and every one, and without fail our flyer cropped up. Then I even mag loaded 5 and fired them, and our flyer cropped up. In each 5-shot group we would get 1 flyer, which is just absolutely inexplicable. I'd switch back over to some of the 140 boat-tail hollow points I had left, load those up in the same magazine, shoot a group, no flyer. So right now we're kind of at a loss as to why I'm getting flyers with the RDF bullets in these 6.5 MATEN. Now, I'm not bad-mouthing the Nosler 140 RDFs, because without the flyer we were shooting some very, very nice tight groups. We just have the inexplicable flyer. And to make sure that it wasn't me, it wasn't the shooter, which is always a possibility. My ego is not so big to think that I can do things perfectly every time. On the same day we had this out, I switched over to the Accuracy International AE Mark II with Krieger barrel in it, shooting 243 cartridges. And it was a known good rifle, known good optic, known good cartridges, all that stuff. And I was able to shoot a group that was under ½ minute of angle with no flyers whatsoever with that system. And I didn't get flyers at all, any groups I shot. with that rifle. So I was pretty sure that it wasn't the shooter that was kicking those out. But yet it's curious that no matter how we mix those cartridges up, we still seem to only get one flyer out of 5. Now, I haven't shot extended groups, haven't shot 10-shot groups, 20-shot groups, etc. That will be the next time that we go out. But we're running up on our deadline for Guardian to get this guy ready. The AE Mark II is ready. It does have ammunition ready to go, so if I really get frustrated with this guy, you guys will see me at Guardian with the AE Mark II. That is my go-to rifle. If I just need a rifle to go shoot a match, that rifle stays set up, it stays ready to go. But it's fun to go out and try to figure these problems out. This is why I like precision shooting. I like the science of it. I like trying to figure things out. Our next step with the Nosler 140 RDFs is going to be to pull the 260 Remington out of the safe, get a load worked up for it with these guys. And with the 260 Remington, we'll have a little bit more control over our seating depth. We'll have a little bit control over some other factors. I won't have to worry about single loading versus mag loading versus semi-auto loading. And we'll be able to test the cartridge, or I'm sorry, the bullet, a little bit more, under a little bit tighter tolerances in that setup. So before we actually finally report on how well the RDFs work, I want to actually test them in a bolt action system, not just in our semi-automatic. And we'll see how well those work. The chamber on the 700 is cut a little bit tighter. The lead is a little bit shorter, so we can play around with seating depth a little bit better. With the MATEN here, we're kind of locked into our seating depth with the magazine. When we're feeding from the magazine into this barrel, we already have a pretty good jump to start with, and we really can't close up that jump and still feed from the magazine. So we are kind of tied up a little bit on that. But that's the current state with the RDFs. Again, a really exciting bullet. On paper, they look really great. But what really got us into wondering about this flyer issue is it's not just us that have experienced it. I've talked to a couple of other shooters that when they went through their load workups, they kept getting these flyers, and those are in high-grade match bolt guns that they were seeing these. And they could kind of back into a seating depth that would reduce the tendency of flyers, but they would still crop up every now and again. These bullets, for some reason, even though they're a VLD design, what we're hearing back from other shooters is they like a longer jump than your average VLD, which that was initially what made me lock onto them for the 6.5 Creedmoor MATEN project, is because we have to have a bullet that can jump. So right now they're not performing as good as the 140 ELDs or the 140 Bowtail hollow points or even the 140 AMAXs in this rifle. But hopefully we can get that tuned in, get rid of that flyer. I would even take a little bit larger aggregate group size if I could get rid of the flyer and bring the flyer in to the rest of the group. So I would love to hear your comments in the comments section down below. Have you guys tried these bullets? Have you run into the issue with flyers with them? Have you shot them at long range and found a G7 ballistic coefficient that works for you? Please let us know. Again, I may take this to Guardian and just run it because I really like shooting this rifle. The things that make this rifle absolutely fun, especially when we're going to be shooting in a really sloppy, nasty condition, which I think the range is still going to be pretty muddy, maybe a little wet down at front line. The brass catcher is a really nice feature to have. Now, I'll tell you real quick on this brass catcher. This is from Tactical Brass Recovery. We've reviewed one of their catchers in the past. This has a different feature. The one we had in the past attached to the top, the 12 o'clock Picatinny rail and locked in, and you really didn't have a way to be able to check your chamber quickly without taking the brass catcher off. This one utilizes a hinge here and attaches to the side of the rifle, the 3 o'clock rail, and it allows us to quickly flip the catcher to the side to either clear jams or to check the condition of the rifle. That makes it real nice because when you've got it in place, you finish shooting your stage, you can lock your bolt back, which will catch that last live round that's in there if you're running more rounds than necessary to shoot the stage. Then you can flip the guy open, the RO can verify, and you can come off the stage with your brass catcher and all your brass in place. I like running a brass catcher whenever I do run a semi-automatic system because we don't run into a lot of malfunctions, especially with the tactical brass recovery catchers. And it allows you to just be a little bit more relaxed because as soon as I'm done, I can walk off the stage, I can clear my mind, I can think about how the stage went or how I can improve. I'm not scrambling around trying to pick up my brass. And then when we get to the end of the match, I don't have to go over to the pile and sit there and try to pick my brass out of the pile. I actually, when I'm running a brass catcher like this, very often I don't even mark my brass because the large percentage of it will end up in the brass catcher. You may drop one or two. This system has a tendency, for whatever reason, on the last cartridge in the magazine, once the magazine locks back, every now and again I will find an empty sitting on the follower of the magazine. And that has more to do with moving the system around with a piece of brass waiting in the top stage of the carrier. I've never had a situation where it's jammed with this carrier, so we're not having brass bounce back in. I think it's rolling back in after the fact when the bolt's locked back. But it's a really nice system overall. We'll have a full review coming up soon, but it's really great. It's easy to fold up, and one thing I really like about the hinge is I can fold this guy forward and keep it stowed that way. So if you're on a range that requires a chamber flag or requires your chamber to be locked open whenever you're not on the line, then I can fold the brass catcher forward, have my chamber locked open. Everybody can see that the gun is clear instead of having it folded back like that or have it sit out to the side and worry about getting it damaged. It is a really beefy overall setup. I haven't worried about breaking it, and especially when I'm single loading, the brass catcher design is really great because I can have it open, I can have it closed, I can fire my shot, it catches my round, flip it open, single load the next one, flip it back, fire my shot, etc., and not have to chase cartridges flopping around on the ground, or get the eventual cartridge that will roll underneath my arm and burn me pretty good. So tactical brass recovery brass catcher has really worked well for us, and I love shooting the semi-automatic rifles because I don't have to worry about chasing that brass. So it's really made me get this rifle out a whole lot more often. That's about it for our Mail Call Mondays today. I hope you guys have liked this episode. If you have, please make sure you like, share, and subscribe. If you have a question that you'd like to be answered on next Mail Call Mondays, feel free to leave it in the comments section down below. And if you have questions on anything, please send it to us on Facebook or Twitter, or drop it in the comments below. And until next time, get out and shoot!